Welcome to EDU World Space.
Okay, so this is the force diagram for the bar. So let's take a look at the moments about point A. Consider counterclockwise moment is positive, therefore clockwise moment is negative. And this will give us NB times 13 feet minus W times 8 feet, and then times cosine theta is equal to 0. And we know cosine theta can be expressed as 12 feet over 13 feet, which is equal to 12 over 13. So eventually you have NB, which is the normal force at point B, is equal to 57 pounds. So now let's apply force equilibrium for this question. So the net force along xy direction is equal to 0. So the net force along x direction can be equal to Fa plus Fb cosine theta minus Nb sine theta is equal to 0, which means that Fa is equal to Nb sine theta minus Fb cosine theta. Fa here is the friction at point A, and Fb here is the friction at point B. So on y direction, we have Na minus W plus Nb cosine theta plus Fb sine theta is equal to 0. Therefore, we have Na is equal to W minus Nb cosine theta minus Fb sine theta. Na here is the normal force at point A. W is the gravity of the bar. So we know sine theta can be equal to 5 feet over 13 feet, which is equal to 5 over 13. And we also know that since the bar is in equilibrium, therefore the friction at point A and B is the static friction. So I have Fb is equal to mu s Nb and Fa is equal to mu s Na. So if we do some arrangement here, we have mu s Na is equal to Nb times 5 over 13 minus mu s Nb times 12 over 13 based on the equation here. And then we'll have Na is equal to W minus Nb times 12 over 13 minus mu s Nb times 5 over 13 based on the equation here. So now we can multiply by mu s at both sides. And this will give us mu s Na is equal to mu s W minus mu s Nb times 12 over 13 minus mu s squared times Nb times 5 over 13. And then we can set these two equations equal to each other. So we have Nb times 5 over 13 minus mu s Nb times 12 over 13 is equal to mu s W minus mu s Nb times 12 over 13 minus mu s squared times Nb times 5 over 13. As you can tell, mu s Nb times 12 over 13 here can be cancelled out. And this will give us such equation here. And then if we do some arrangement here, we have such equation here. We know the gravity of the bar is given as 100 pounds, and the normal force at point B is 57 pounds. So now we can plug in these values back into the equation. We'll have such equation here. So now let's divide it by negative 22 pounds on each side. And this will give us such equation here. So now we can apply the formula to determine the coefficient of the side friction in this case. So there should be two solutions here. So the first solution is 0.232, and the second one is 4.31. So we know the coefficient of the static friction is never greater than 1 because it's between 0 and 1. Therefore, the only answer for this question is mu s equal to 0.232. And this is the answer for this question.